Hi, I'm about to try to make some videos of doing projectiles. This is a bit new for me, so you'll probably find I'll get better as I go, but let's go from the beginning. So beginning, we're going to project an object upwards with an initial velocity of 100 meters per second. And we want to find out a few things. It's going to take a path upwards and then fall back to the ground. We want to know what the time of flight is. We want to know what its maximum height is. And we want to know what its impact velocity is. So let's see how we go. Now, a few things. We're going to use U-arm equations. These are uniformly accelerated rectilinear motion, uniformly accelerated motion in a straight line. Now, our initial velocity is 100 meters per second. I'm going to say plus because it's going upwards. For objects that are rising, falling relative to the Earth, they will always have an acceleration which is downwards, and so I'm going to say minus 9.8 meters per second squared. This is meters per second. This is meters per second squared. We're going to say our displacement. Now it starts here and finishes here, so vertically, I'm actually looking at vertical motion here. Vertically, our displacement is 0. Our displacement is vertically, how far have we gone vertically from where we start to where we finish, and the answer is 0. That's our displacement. And the thing we're trying to find is time. We're going to use S equals ut plus half a t squared. That's one of the 4 U-arm equations, which you probably already know. So here we have 0 equals u, which is 100 t, plus half times minus 9.8 t squared. That comes out as 0 equals 100 t minus 4.9 t squared. Half of minus 9.8 is minus 4.9. Now I quite like to make this a positive, so I'm going to put it on the other side, and we get 4.9 t squared minus 100 t, putting this over the other side, equals 0. 100 t. I'm going to factorise that by taking out 2, which is common to both of these. 4.9 t minus 100 equals 0. Then either t is 0 or 4.9 t minus 100 equals 0. One of those things is true. We know that because if you've got a product AB equals 0, then either A equals 0 or B equals 0. Or they both might be. So now we're going to say 4.9 t minus 100 equals 0. Therefore, t equals 100 over 4.9 seconds. And just going to do that on the calculator. 100 divided by 4.9 equals 20.4 seconds. 20.4 seconds. Now you can have a bit of a check to make sure that that's right. If you're travelling 100 meters per second, it's going to take you 10 seconds roughly to reach your maximum height, 10 seconds to fall again, so it's about 20 seconds, which is pretty right. Then, after that, let's have a look at the maximum height. Again, we're looking at vertical motion only. That's all there is. And we have the initial velocity is 100. Acceleration is minus 9.8. S max is what we want to find out. And the other thing we need to know is that at the maximum height, its vertical velocity, right at the maximum height, it stops. So its final velocity, v, is 0 at the maximum height. And here we can use v squared equals u squared plus 2as. 0 equals 100 squared. 2a is 2 times minus 9.8, so that's minus 19.6, minus 19.6s Therefore, S is 100 squared over 19.6. I'm not really showing you how to do that algebra. You probably need to learn how to do that. Comes out as 510.2 metres. And the final thing was the impact velocity. It accelerates upwards at 9.8 metres per second, and it accelerates downwards at 9.8 metres per second. That wasn't very well said. It's still accelerating downwards, but it's losing 9.8 metres per second as it goes up. It's gaining 9.8 metres per second as it's falling. So the impact velocity is going to be 100 metres per second. Downwards. We could probably have answered that right from the word go. Okay, good.